Hello, welcome to Comrade Tutor's tutorials. This session will focus on unit and dimension. Unit and dimension are very important topics, and we need to understand it because it's very, very fundamental to understanding physics. So, the first thing we need to understand is the difference between fundamental and derived units. As the name implies, fundamental units are units that do not depend on other units for their expression. Example, you have length. Length can be measured in meter, mass in kilogram, time in second, and you can see their symbol. mkg, and s. And these are standard international units. On the other hand, derived units depend on the fundamental units. So you have your quantities, the derivation of the unit, which is very, very important, and the units and the symbol. Okay, let's look at area. Area is length times width, and the length is measured in meter, width in meter. So you have meter times meter, okay, to give you meter square. So you have volume, which is length times width times height. That's where you get your meter cube. So we have density. The formula for density is mass over volume. So mass is expressed in kg and volume is expressed in meter cube. And that's how you have the formula for density as kg per meter cube. You have acceleration, which is a velocity over time. So if you divide a unit of velocity with the unit of time, you have meter per second square. Force is acceleration, mass times acceleration. And kg is the unit of mass, and meter per second square is the unit of acceleration. So if you simplify, you have kg meter per second square. You also know that this unit is regarded as Newton. So you can use N to express force. Weight is similar to force. The only difference is that the acceleration due to gravity is a constant, okay, which can be 9.8 or 10 meters per second square. So apart from that, the units and symbols will be the same, okay? So moments can be calculated using force times distance, perpendicular distance. Okay, so force, as we can see above, can be calculated using kg meter per second square. So times the distance, which is this, and that will give us this, okay? So up here, you can express the unit this way. You can also take note that this is Newton, okay, so that you can express the unit of moment as Newton meter. Okay, so let's do a little example. Okay, so Hooke's law can be expressed as the product of spring constant and extension. Okay, the force in the spring is proportional to the extension. Okay, so basically F is equal to KE. Okay, so we want to find the unit of the spring constant. So what we are going to do is to make K the subject of the formula. If we make K the subject of the formula, we have that K is equal to force over extension. So if you substitute the unit, which you already have above, so this unit here represents the force, Y meter here represents the unit of extension. If you simplify, you have it this way. However, you can leave it such that this unit will represent force, that is Newton, and your meter will be there. So you can still have it as Newton per meter. Okay, so the second section of this tutorial will be a dimension. Now, dimension is basically expression of all the quantities, okay, in terms of the length, mass, and time. So notice that length here is represented as L, mass is represented as M, and T is represented as represents time. Okay, so you have L, M, T. Okay, so let's convert what we've done above into dimension. So we have the quantities. Okay, we have the quantities, unit, and their dimension. Basically, you can derive the dimension from the units, and vice versa. You can derive the units from the dimension. So take, for instance, area. Area is meter squared. So you know that meter squared is just length times another length, whether the length is length times width or distance times, you know, another form of distance. It doesn't matter what is described as. Once it's area, if you are multiplying to length. So that's why you have the dimension as length squared. So volume is also multiplication of three lengths. So you have it as L cubed. So density is mass over volume. So this is the mass divided by the volume. Okay, so you have it this way. You can also express it in linear form so that you can have it this way. So velocity is meter per second, and you can have it this way. Meter is just a measure of length, and T is the dimension of time. Okay, so you can have it in linear form, LT raised to power minus 1. So acceleration is meter per second squared. So you have it this way or this way. So the same thing with force. You can see the importance of expressing your units in each composite exact components in terms of mass, length, and time. Okay, if you express it as Newton, you still need to break it down into the three units for expressing dimension. Okay, so you have it as mass, length per time squared. Okay, you can also express it in linear form. So weight is the same as force, as explained above. The only difference is that the acceleration in the case of weight is a constant. Okay, acceleration due to gravity. So moment is equal to force times perpendicular distance. So you see have it this way: force times distance. Okay, so if you express this in its dimension, you have kg, that is m squared is L squared, and S squared is T squared. So that is it. So it's really good. So what we'll do is we'll produce another video where you can use dimension to investigate problems. For instance, you don't know a formula, okay, but you can use the units of the quantities provided in the equation to, gaze the formula, okay, and solve it and get an accurate result. For more tutorials, I will recommend you go online, go to www.comradetutors.com and register. Our experts will get in touch with you. Most of our tutors are master's holders and PhD students, enthusiastic teachers. And you can learn virtually via Zoom or Teams at the comfort of your home, and you can pay securely online. So I look forward to producing another edition of our short clips for our students. Thank you.